So whenever hydrogen is produced with sodium, it means directly that it's an alcohol. It shows us directly that it's an alcohol. J and K give orange red precipitate when reacted with 2,4-D and pH, which means that J and K are carbonyl compounds. But only K reacts with Fehling's solution. Fehling's, you must notice that Fehling's solution is for ketones, right? Right? Am I right? Fehling's solution is for ketone. Yes, so ketones do not react. This is the aldehydes that react with Fehling solution, but only K reacts with Fehling solution. Directly we can get the inference. H is an alcohol. J, so you see K reacts with Fehling's means K is an aldehyde. J, which means J is a ketone. J, from the DNPH test we know that J and K are carbonyl, which means they can be ketone or aldehyde. We know K is an aldehyde from its reaction with Fehling's reagent, and J is not an aldehyde, which means it has to be a ketone. So H, so first we are drawing H, so you must notice it is C4H8O. 8O, which formula they have, they ask for structural. Okay, so whenever they ask for structural formula, it means that you do not show any bonds. Okay, you do not show too many bonds. So there are 3 isomers of H, which means, so C4, CH3, CH2, CH2OH. 3 plus 2 plus 2 gives you 7. It's the 8th, right? CH3, CH2, CH2OH. But are you sure it's C4H8O? Yeah, C4H8O, yeah. Oh, but there are no 4C, there's only 3, right? So we need to put in another one. So just put C, each 2, and then we put a double bond, CH, CH2, CH2OH. Remember, we can move the double bond round and round, so we just put CH3, CH, CH, CH2, OH. So you can see now, next time I'll move the double bond there. So I'll have CH3, CH2, or alternatively, you can move the OH around. So you can have CH2, it's the same as the first one, except that we keep the OH there. So why did I put the OH here? So I just want to show you that instead of moving the double bond, we can also move the OH. So you can move 2 things. J is obviously a ketone, which means it has a non-terminal carbon, sorry. CH3, CH2, CO, CH3. Aldehyde has a terminal carbon, CH3, CH2, CH2, CHO. Right? So you can see it's the same, except that I moved the O here and there. So they have 3 of H, so they probably wouldn't be asking you a lot about H. In addition to being structural isomers of each other, some of the possible structures for H, J, or K, so Cis-trans isomerism. Draw the display formula for these isomers which show this Cis-trans isomerism. So Cis-trans isomerism occurs due to limited rotation about CC double bonds. You must observe that CC double bonds are possible. Cis-trans are not possible in the first one. Why? What would be it like? So each, because the 2 are the same, they cannot have a cis-trans. Right here, yes, okay. So now we are gonna take this one. CH3CH equal to, so obviously we need to have this one. This one is the main thing, so we'll put a H here and then we'll put a CH3 here, right? CH3 CH CH2OH. So CH, we put the H, CH2OH, and then we just flip this around, means the H goes down and the CH2OH goes up. So the CC still remains the same. One would be a H, one would be a CH3, and then this will be, oh wait, this asks for display formula. Display formula means that you need to draw out each and every bond. So it means that what we've drawn here is a bit wrong. So now I'll demonstrate what actually had to be drawn. So you had to draw this, and this, it was CH3, right? So H and H and another H. So I know it's a very tiring job, but you have to draw it for your marks. CH2OH, C H2OH. So this is a cis isomer. So again we have to erase this part. CH3, and then H, and then this part goes up there, so CH3 CH2OH, so CH2OH, and then down here is another H. So this is the trans isomer, this is the trans isomer. Okay, draw the display formula of those isomers which are chiral, indicating in each case a chiral carbon atom with an asterisk. They always ask you to do this. They ask you to draw the chiral carbon atom with an asterisk. So yeah, so we need to get the asterisk done. So which one of them is chiral? So it has to be not a carbon, it cannot be a carbon with a double bond, it must have 4 different things attached to it. So the chiral carbon atom is, which one is it? CH3, CH2, can it be J? Maybe. Can it be K? Maybe. So if we draw this up, it'll be like this, CH3, CH2. So I'm just drawing this up for simplicity's sake. COCH3. This is double bond, of course. So here you can see there's an H here, there's the same H here. So mark it again, H, H. So there's no way that can be chiral. Right? Okay, so there's no way that can be chiral. Here is again CH3. This can no way can be chiral. CH2. So again, whenever there's a CH2 involved, we cannot have one. Right? But however, can we have it here? Oh, but there's a double bond here, so it's not possible. Okay, can it be this one? Which one can it be? So okay, I'll draw it out. I'll show it to you. C4H8O. So C, oops. So C4, C4H8O. So I'll directly connect it to a CH. there is H dot 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 and the OH, and you must notice that C to C H H and the H there. So you must notice that this is a chiral. So you can either draw it the non-superimposable isomer of what I've drawn, or you can just draw this one. Okay, either how. Anyhow, it's both of them are acceptable, so I just drew one, so it's acceptable, right? Because they just said, so they said this isomer, so it's enough if you just draw one isomer. So you only get 1 mark for this and 1 mark for the chiral carbon center. So this is just 2 marks. This is just, you must remember, as 2 marks. What really matters is not even this one, it's just 1 mark. So don't waste too much time on the last 2 questions. What really matters is that you got this correct. This is what really counts, is your 5 marks that count. Is those 5 marks that really count towards your marks. So make sure you get the first part correct. It doesn't mean even if you get the last part wrong. So you see, the first part is easy and they give you a lot of marks. The second part is hard, but they give you 2 less of marks. So you must remember that to try all, but if you are not able to do the last question, just let it be. Okay. Yeah. And I'll end the question paper here. Paper 23, October, November 2012. See you guys in the next video.